Hello, Namaskar, welcome to Learning-Riti. Today we are going to start our first chapter of class 11 physics, and today's chapter name is physical world, and in this lecture we are going to cover the first topic of this chapter, and the name of this topic is what is physics. So this is a very important question when we are going to study the physics. So first we should understand what is physics, what is its mean. So let's begin with it. My name is Dr. Hemant and we are going to see what is physics. So physics is one of the most fundamental of sciences. So the question comes when we talk that physics is one of the most fundamental of science, then what is science? Science is a systematic attempt to understand the natural phenomena in much deeper and greater details, and also to use this learnings, the understanding from this phenomena to predict and to modify or control the other phenomena based on it. So now you understand that it's nothing but a systematic attempt to understand the natural phenomena. And why to understand it? Because so that we can predict, modify and control the phenomena which based on similar events. So the word science originates from the Latin verb scientia. The meaning of scientia is to know. This is also you can say in Sanskrit. Sanskrit word is vigyan, and also you can call it in Arabic it is ilm. Both meaning is knowledge. So this word, now you can see that this originates from the word Latin verb scientia, meaning to know, and also science we call it in vigyan in Sanskrit, and in Arabic ilm, and the whole meaning in all the word have is that knowledge. So ultimately science is nothing but is a kind of knowledge which we are going to gather with, which have different process involved in it. So we will see how we can further make our understanding about science in greater detail. So it involves several interconnected steps. For example, it must have systematic observations, and then you should have a controlled experiment, and then quantitative and qualitative reasoning, mathematical modeling, prediction, verification and falsification of theory. So let me make you understand this part with the help of some examples. So for example, let's say no, you see the objects, when objects which falls, once you drop it, it falls down, right? So the observation is that it is falling down. So not only this, any object you take, and if you drop it, it will fall down, it will not go up. So this is the observation. So if you what is systematic observation? It is not just an object, you took many other objects together and dropped it, right? So you did a systematic observation that if you are dropping different objects, then it is dropping down. So this is kind of and a very simple example to let you know that what you mean by systematic observation. Then again, when you plan it to drop it, so you made a controlled experiment. So it's not like that it dropped automatically. You design it that you should drop it from here, from top, from first floor, for second floor. So this is your controlled experiment. You are going to drop different objects from different heights or different places. Then the terms comes that qualitative and quantitative reasoning. So what it means is that for example, when you are dropping an object, then you decide, okay, as I said, that dropping from 10-meter height or 20-meter height, you made a quantitative approach to it, right? And also you are dropping a heavy mass, for example 2 kilogram object, 3 kilogram object, or just 100-gram object. So this kind of reasoning you should have, quantitative and qualitative, that if you want to study the behavior of different objects which is falling from different heights, having different masses, so then of course you should have to give a quantitative meaning, that what is the height, what is the mass, something like that. And of course it is a controlled experiment, because you are going to pre-design your experiment, that from where to fall, what should be the choice of your weight and different heights. Now whenever you do experiments, you do the mathematical modeling because you make observations, and then once you make your observations, then you try to derive it, like how we can predict it for any object, right? Then you try to make a equation, and there comes the mathematical modeling, so that you can use this observation, this experiment results to build up an equation which can be used to predict any similar events if it have a matching condition. So there comes your mathematical modeling, which is going to be very helpful when you are going to work on very complex system and very complex phenomena, where this simpler approaches can be of very much use. And of course, as I mentioned, then once you have this verified, you have a complete good model based on your controlled experiment and systematic observation, then you can have a prediction, right? Prediction in the sense that now you know that if I did the experiment for 2 kilogram object, for 10 meter height, 20 meter height, for 100 gram object. Now if my theory is correct and my experiment is correct, it is validating it, then I believe that if I use 100 kg, 200 kg object, it should follow the same model, and I should be able to predict that it should reach where it should fall there. If I throw it, then where it will fly and all. So you will see lots of similar coming concepts, theories in the coming physics chapter sessions. This is just to beginning to give you a brief that what is science and how it have different interconnected steps. And of course there is no the one theory is not always like it is always remain true. Once you find something new, it will be modified or it will be updated, or if it is not satisfying any new observation, then we may have to come up with the new theory. So this is all the procedure where the interconnected steps are involved, and then how we proceed in this direction in future. All right. So as I mentioned that science is ever dynamic. There is no final theory in it. There is always a chance that it can be updated if someone is observing a new phenomena, and then they are finding, okay, the existing theory or principle is not able to justify it, not able to explain it, then you have to come up with something new, and then you can come up with some new theories or explanations which are able to explain the new observation as well as all the previous observation. Then your phenomena, your concept, your theory becomes well validated, and we may have to discard the previous one which is not able to explain that. So when we talk about the basis for the progress of science, and it is the interplay between the experiment and theory and the observation. Observation means the experiment. So these two parts, theory and experiment, go hand in hand to when we are talking about that science progress and how we are evolving different theories, and we are able to predict much more and complex concepts and the phenomena which is happening in our nature. So the very important fact about science is that like we cannot make rules which nature follow. Always remember that in science we try to find the rules and the laws which is operating nature. It's not like that we can make a rule and law which nature will operate. It is never like that. It is always that we search for those operating laws and laws how the nature is behaving, what nature is following. We are not making any rule and law which we can vice versa for nature. And also there is always the scope for speculation and conjecture in science, because you can always make some predictions, some guesses. It may be sometimes wrong, sometimes it can be very true, and that may be needed to explain certain behaviors in physics, in science, and without that you may not come up with the new approaches, new concepts. So whenever you guess something, or when you come up with some ideas like that it should be happening something like that, then you can explain it, but it's not like it will be considered as a valid theory or principle until unless you verify it with the relevant observation and experiment. So this is very important. Like whenever you guess something, that it can be the possible explanation for a given phenomena which is happening right now, so you must verify it with the relevant observation and experiment, because it should have a wider scope. It should not be explaining that only that part of the phenomena. It should be explaining any wider range of the phenomena which is of similar kind. So that is very important. But of course you are free to have guesses and speculations to come up with the new ideas, and you do your future experiment on that. So coming back to the very first question, that what is physics then? Now we understand that science is nothing but a systematic attempt. We have lots of interconnected steps, which is very important for progress of science. We can have speculations, we can have new theories. If we can discard the old one, there is no final theory in it. So all applies to physics because it is also part of science. But now what makes it very unique and why we study in the domain of physics? So let's have a look at it. What is physics? So again comes the word physics. The word comes from Greek word nature. In Sanskrit we call it bhautiki. That is used to refer the physical world. And the very important fact about physics is that all disciplines, it is used in all disciplines, whether it is a physicist or a biologist or a medicine, or you talk about space, chemistry, everywhere the ideas of physics are used. So this is a very widely used concepts or theories, and explaining, because as I said that it is nothing but that exploring and then coming with the natural the physical world, the happenings around us is all about we are going to study in physics. And it's the foundation of all engineering and technology. For example, you could not have imagined a television or radio which you are on, the computer or monitor where you are watching this video, this lecture, the mobile, and also the space communications are happening, the satellites which are communicating with us, and the internet and all you are getting through the wireless communication and everything. It is all possible because of this technology, and of course there are the theories of concepts which are observed from phenomena, understanding the phenomena, and different controlled experiment have brought this kind of result in front of us. This is, you can see, the steam engine. Now we have a diesel engine and electric engines running on the tracks, railways. You might have traveled to those, but these are all possible and have made your life easier, and this is all the result of understanding of those basic laws of thermodynamics and mechanics which is just studied under physics. Spacecraft, we are always hearing that in future, or we are going to exploring the space around us, what is beyond Earth, and all this is possible because this kind of space we have. And this spacecraft are also lots of theories and concepts goes into it from physics, and then the understanding, and then we have gone to this level that now we are not only on Earth, we are able to even explore the universe. So you may find that studying physics is nothing but nothing less than an adventure. It can be challenging, and sometimes it can be very frustrating as well, because sometimes you are trying to understand something and you are not able to clear your concept in that, and then you may find it very frustrating. But a very important point that once you start understanding it, you will find it is the most rewarding and satisfying subject. And means you will find it once you understand and you go do it deep into to the subject, and then I'm sure that you will feel the same as I feel here. So again, coming back to the very precise answer to the question, what is physics? So physics is the study of nature and its law. It's an experimental science where physicists observe the phenomena of nature and try to find patterns and principles that lead to this phenomena. So as I mentioned, for example, dropping of the objects from top to bottom, it is always going down. So you try to find a pattern, like if it is going to the bottom from top, then what is happening when you are dropping it from different heights? What is happening when you are dropping off different mass sizes or different masses? So this is all you are trying to find a pattern and making observation, and then you are come with the models, theories, and to explain it, and then you can have a similar observation explained if you have the basic theories made on that. So you can do the prediction and also lots of guesses in that. So a very important aspect comes with that theory and what is physical laws and principles. The pattern which you are now exploring, that you are seeing, you call it theories, and if these theories are well established and have become of broad use, then they are also known as physical laws and principles. In physics, we try to attempt to derive the properties of much bigger and complex system using the very basic simple and concept and interaction of different constituent particles and systems, and this approach is called reductionism, and this is the heart of physics. And what do you mean by reductionism? Means for example, you see that simple falling of apple, which Newton have established that it is gravity which is causing that apple is falling from the tree to the ground, and he come up with that law, Newton's law, if you know, very well known law. And the same law can be explained the rotation of earth around the sun and then the rotation of moon around the earth. So you can see that a simple observation where Newton have made that earth is the apple is falling on earth ground, and that is the reason is gravity, and the concept is now applicable in a much wider range where we are talking about earth and sun and moon and earth and the rotation. So you can see that how a simple observation is able to explain a much complex system, and now we are able to predict that how the earth is moving around, how much time it will take moving around sun, and what are the parameters which is influencing the motion of earth around sun and the motion of moon around earth. So the development of physical theory requires creativity at every stage. As a physicist, you must learn to ask appropriate questions, design experiments to try to answer the questions and draw appropriate conclusions from the results. So to make you understand this, let us come back to the Galileo experiment. So what he did is that he thought that he was trying to find out, okay, if I have two objects of different weights, and if I make it fall from top, and then what would be the rate of fall, whether the two different masses will fall with the same rate or the different rate. So this curiosity brought him very important creativity, and he know that he had to perform a systematic experiment for it to come up with that answer to it, and that answer would be having a lots of scope, and you might see in future as well once you are going into deep of this physics study, that how this rate of and mass dependence have a crucial role in predicting lots of other aspect into it. So what he did is that he made a ball of two different masses fall from the Pisa tower, and they fall, and he noted down this, he did the experiment and noted down that the rate of fall, and he come up with a very good idea which later bring lots of development in the field of gravity. So it's nothing but physics is nothing but a collection of facts and principles. It is also the process by which we arrive at general principles that describe how the physical universe behaves. So for example, sometimes what happens that you may come up with that new phenomena and you are not able to explain it with the existing one, and then you might have to come up with a new ideas to explain. Or sometimes what would happen that you may find it is something new, you are not able to explain, but it's not like it is not explainable. You may not know that this theory already exists, you just have to correlate those existing theories and try to explain that, find that if you can explain by the existing theory, and then you try to see if certain modification is required, or just you need a completely new domain exploration and theory and principle exploration to explain this kind of thing. So it is just not the collection of facts and principles, the process involved in it to learn from one step to other step to arrive to the final conclusion. And there can be many considerations of new modifications, or sometimes rejection, and new pole theory can be rejected completely and a completely new theory can be come up with that. So and a very important point in physics is that there is no final theory ever regarded as final or ultimate truth. So there is always a scope of improvement, and if tomorrow I come up with a new phenomena which cannot be explained by any of the old phenomena, observed theories or principles, then we have to come up with a new one. And then this is how our scientists Einstein, Newton, Feynman have become great scientists, because at that time, based on their observation which they did at that time, they come up with the laws and theories which became very useful and very important for development of science and physics, and we see lots of progress around us, and also it have made our life easier. So this is the similar way in physics. You make a greater observations and you come up with your idea, try to explain it with your existing theories and phenomena. If you are not able to explain with the existing one, then of course you can come up with the new ideas and you can become one of the greatest scientists which the history will see in future. So every physical theory, the very important point here, every physical theory has a range of validity outside which it is not applicable. Often a new development of physics extends the principal range of validity. What it means is that, let me explain you again with an example. So we talk about the Galileo experiment, right? So when you talk about Galileo experiment, then he dropped 2 balls. So consider let's say you are going to Pisa Tower. Now you are not dropping off 2 balls, you are going to drop a feather of bird. They have this feather, you drop that and 1 ball, and you drop it from the same height, and now you expect as per Galileo that they should have the same rate, because as per Galileo experiment it is independent of mass. But if you do that, you will find that ball will come first and feather will not, because here one important aspect is neglected, is that the resistance of the air in between. So there is always air in the atmosphere, and the feather is much lighter and the resistance is more effective on it, so that will decelerate it, and then you will not see the rate same. But it doesn't mean that Galileo is wrong. Galileo is right. If you do the same experiment in vacuum, this is true, you will always find the both are coming with the same rate. So meaning to say that this experiment which he have done, it have its own validity range. In vacuum it is true, but maybe in air it's not, because the one more factor come into picture, that is the friction of air, right? Where it is negligible, your Galileo is right. Otherwise the other experiment where you have to account for the friction, and then you just did a modification to the theory, and now it becomes an it have now a wider range. Earlier now it was applicable for only vacuum, now it have extended its range. Now with this modification, now you can apply the same concept to, once you add the modification and take account in the models or equation for the friction, then you can account for a wider range, where now you can talk whether it is in air or vacuum, this rule applies. So this is how the meaning here to say that a new development in physics extends the principal range of validity, and of course that there is always a range of scope where the given law is applicable or valid. So in physics, as a physicist, you should have a better understanding of it, that what laws or principle you are going to apply, whether it is valid for this situation or not. That understanding, once you build up, then that would make you a very good physicist and a very good scientist in that time. So the next question comes now. I think I might have made you clear that what is physics. Then the very next question comes, then what is physics? Then why physics, right? The main objective of the physics is to know the basic principles that govern the phenomena occurring in nature, and finally to use those fundamental principles to predict the results of the further future experiments. And this is very crucial, because why we are studying something, because we want to predict something, to make something that what would happen if something happening, some disaster is coming, then can we have enough understanding, and that understanding will come if we do the experiment, we understand the phenomena, and then we will be able to predict. We can save lives, we can make our life easier, and we can proceed further. We all have make our life enjoyable. So in summary, we can say that the purpose of physics is to improve the technology, to make the technology better, or to have a technological development, improvement in lifestyle, and then protection against natural disaster. You can see lots of cyclones or earthquakes are coming, and then our scientists are working day and night to figure out whether we can have some models, some predictions, so that we are with the observation in a real time. If we can predict that something is going to happen, you can avoid lots of catastrophe or lots of loss of lives and loss of capital investment in there. So there you can think of that, how it can be very beneficial, and their understanding of physics and science becomes very, very crucial. So I think I have made you clear that what is science, what is physics, and I want to end this lecture with a very, very important, very nice thought which I like, and I hope that at one day, once you have a very good understanding of physics and science, you will agree with me, and also of course given by Einstein, and I think you will be of much appreciable to this statement. And the statement says that the supreme task of the physicist is the discovery of the most general elementary laws from which the word picture can be deduced logically. But there is no logical way to discovery of these elemental laws. There is only the way of intuition, which is helped by a feeling of the order lying behind the appearance, and this empathy is developed by experience. So I think you will be able to understand this meaning, if not today, but tomorrow, once you have a very good understanding of physics and the related topic. So with this, I will close this chapter and will meet you again in our next topic lecture, which is scope and excitement of physics.